Okay, so I wanted to do a quick video just to show you quite a nice, efficient way of dealing with this. When you first see this, you might your first thought might be to do the algebraic division, which is good, and that would look like this. So 9x squared minus 16 divides into the quadratic exactly once with 25x plus 32 left over, and then we could write it like this, and we've found that a must equal 1, and you would then carry on as before to express that part in partial fractions to find b and c. So what I wanted to show you is, rather than doing this algebraic division, an alternative quick method. So first of all, start with your fraction that we're trying to simplify, and especially because there's 9x squared on the top and 9x squared on the bottom, we're just going to write the top 9x squared, and I'm going to put a minus 16 there to make it look like what's on the bottom, and then I'm going to add 16 back and then add the 25x plus 16 back to that. So now what I've got on the top is exactly the same, both sides, and I've got this 9x squared minus 16 within that numerator. At this point then I can see that that must equal 1. So I've got 1 plus 25x plus 32 over the denominator, and then carry on as you would over here. So there's a few situations where this is a really nice way of doing it, and especially when the highest order in the numerator is the same as the highest order in the denominator. So it's still top heavy, they've got the same order. So let's do a couple of examples. So that's the mark scheme, and you can see they're expecting you to be able to, you always have to be able to do the algebraic division, but sometimes what I'm showing you might be a little bit more efficient. So for example, again, so in this example, we start off with this question and it asks us to write it in partial fractions, and we can see it's a top heavy fraction. We've got the same order. So I would just do, first of all, make the top 4x squared minus 25, just add that minus 25 in so that it looks like the denominator, then add back that 25, and then add back the 25 that was already there. Okay, so what we've got on the top is still the same, 4x squared plus 25, but we can see the denominator in there as well. When I do that, now I can split them out, 4x squared minus 25 over that, so that gives me 1 plus 50 over 4x squared minus 25, and then go ahead with your partial fractions as you normally would. You could even do it in this example as well. I've got x squared top and bottom, but I've got 2 lots of x squared. So what I'm looking for on the top is 2 lots of the denominator. So if I add that in and make it 2 lots of x squared plus 2x minus 3, now I need to sort of come back to making that the same as what I've got over here. So I've got 2x squared, that's fine. Here I've got plus 4x, but I haven't got that over there, so I'm going to need to minus 2x. And then here I've also got minus 6, but I only want minus 3, so I'm going to have to add back a 3. Okay, so now when I multiply at the top, I've got exactly the same as on the left hand side, and on the bottom I've got that x squared plus 2x minus 3. Having done that, I can see that splitting this out, I'm going to have 2 whole ones, and then plus minus 2x plus 3 over my denominator. That's 2x minus 3, or you could have written 2 minus 2x minus 3 over that denominator. Okay, one more example. Again, here your default is probably algebraic division, which would look, let's do that over here, algebraic division. So I carry out the division, it goes in x times with a remainder of 3, and that means that I can write the fraction in this way with the remainder over the divisor. Okay, using the method I've shown you above, you might be able to recognise here that I could rewrite the top, just factorise x out of the first two terms, and then I can see that I've got x plus 3 within that numerator there, and then I've still got that plus 3 at the end. So check the top is x squared plus 3x plus 3 divided by x plus 3. And again here I would make it very explicit that this is what you're doing. We're splitting out this fraction. And then here these cancel and I get back that same answer, x plus, and then that was my remainder, 3 over x plus 3. So it's quite a nice efficient method to use when you can spot it, and it's really for dealing with improper fractions as an alternative to algebraic division. So here's 2 questions for you to try. Pause the video and have a go, remembering in both of these, or in question 2 where it says expressing partial fractions, because it's a top-heavy fraction, you have to deal with that first before you can go to the partial fractions. Okay. And so the answer to question 1, you would have got this whether you did division, algebraic division or not, but here's a quite nice, neat way of just getting straight to the answer. Okay. And on question 2, first rewriting the numerator in this way. And then we can see, let's see, to that, was hoping that that might factorise nicely with an x plus 1 on the bottom, but it doesn't. We get an x minus 1 instead, so we can't cancel that factor. So with this part, we go into our partial fractions, leading to this equation, and hence A and B, and hence our final answer.